In problem 6, we want to know if an advertisement raised awareness for a company's product. If that is true, then the proportion of people who are aware of the product after the ad was run will be greater than the proportion of consumers who were aware of the company's product before the ad was run. Which means the alternative hypothesis is that this difference here is greater than 0. The null hypothesis would be the difference in these proportions would be less than or equal to 0. Since it's an upper tailed test, there's one critical value. It's positive, and it's found in column 0.01 and row infinity of the T table. So the critical value is 2.326. Now, we have a sample of 551 consumers before the ad was run. And then we have a sample of 512 after the ad was run. 222 of the 551 consumers were aware of this product before the ad ran. 264 were aware of the product after the ad ran. Both sets of these numbers are already copied into Excel. There were 551 people in the before sample and 512 people in the after sample. Of the people that were in the before sample, 222 were aware of the company's product. 264 in the after sample were aware of the company's product. The corresponding proportions are found by taking the number of people who are aware of the product and dividing by the corresponding sample size. So 40% of consumers were aware of the company's product before the ad ran. That increased to about 52% after the ad ran. The point estimate of the difference between the population proportions is the after proportion minus the before sample proportion. To compute the standard error of the difference in sample proportions, we have to compute the individual variances of the underlying variables. Now, because the null hypothesis allows for or assumes there is a possibility that the proportions are different, we do not pool the proportions to compute the standard error. So the variance of the underlying variable for before is the corresponding p-bar times 1 minus that p-bar. And the cool thing about Excel is I can calculate the after variance by simply double-clicking on the lower right-hand corner of the cell. The variance of the difference in sample proportions is the sigma squared that corresponds to the before sample divided by the corresponding sample size plus the sigma squared that corresponds to the after sample divided by the after sample size. The standard error is the square root of the thing we just calculated. The test statistic is equal to the point estimate of the difference in proportions divided by the standard error. I'm going to copy the test statistic back into Cengage now to 4 decimal places. The standard error has to be to 6 decimal places. The point estimate of the difference between population proportions is to 5 decimal places. And then the only thing we have left to answer, except for concluding, is the drop-down menu in Part D. The simple proportions are not pooled because they may not be equal under the null hypothesis. To conclude the test, we have to compare the test statistic to the critical value. If the test statistic is greater than the critical value, then we have evidence in support of the alternative hypothesis, and that is the case. So the null hypothesis is rejected. Thus, ABC Fluorine's TV ad raised awareness for its product. We check our work, and we should get everything correct, which we do.